All right, so today you're going to talk about unit conversions, which is also known, aka, also known as dimensional analysis. And that is a lot to write. Okay, now there's lots of different measurement systems out there, and what measurement systems do is they measure physical quantities or physical attributes of nature. One example of the difference between a physical quantity and the units of measurement would be temperature. Okay, so if we're talking about temperature, we can measure temperature in a few different ways. We could say a temperature is 0 degrees Celsius, right? But that same temperature on a different measurement scale, say Kelvin, could be 273 K. And this is also the same thing as saying 32 degrees Fahrenheit. Okay? The physical quantity is the temperature of an object, essentially how warm or cold it is. And the measurement system, okay, is what we use to indicate that, or measure one temperature versus another. Okay? And there are multiple different types of ways of doing that. Okay? And most physical quantities are this way. All right, so another example of this could be distance. Distance, or length if you want. So the physical quantity is like how long something is, and you could say it is 1 meter long. You could say it's 100 centimeters long. You could say that that same length is 3.28 feet. You could say it's 39.37 inches. All right? And, think about the physical world. Do the same thing with mass, right? You can measure it in kilograms or pounds or stone, or there's probably other ones out there that I don't know about, but you kind of get the idea. The physical part of nature that we're measuring is distance or length. The measurement system that we're using would be the actual value that we place on that. Okay. One more example could be frequency. So the idea of frequency is how often something is repeating, right? So you could have, say, a pendulum that swings back and forth. Okay, and you could count, okay, how many times per second does this come back to where it originally was? Or you could have like a wheel spinning around, or like a record player or something like that. You could say, well, how often does this point on the record spin back and come around to me? Okay, so frequency is in per second, okay, which is also known as the hertz. That's one way of measuring it, okay? You could also measure frequency in terms of degrees per second. How many degrees of the circle do we have here? So you could go degrees per second. Okay, how many degrees do we move per second? You could do angular frequency. Now, this is a little beyond where we're going, but you could figure out how many radians go by per second. So these are measurement units, all right, that are talking about the physical idea of how often something repeats or revolves or rotates or so on, okay? And there's different ways of measuring that. So this is the measurement. This is the physical idea or quantity that we're trying to measure, all right? Here's the issue. All of these, okay, can refer to the same thing and are often used even in science. Now, the metric system has tried to alleviate that and has tried to just bring everything into official metric units. So for temperature, officially you're on the K system, Kelvin. Okay, for distance and length, you're on meters. For mass, you're on grams or kilograms. Okay, for frequency, you're on hertz or per second. For amount of stuff, you're on moles, and so on. Okay, sort of what we've been talking about. But because there was an imperial system and it's still lingering around, we might get measurements in different measurement systems. And what we need to do is find a way to turn one into the other. Okay, and that's what this will be all about. Okay, so we're going to start with a fairly straightforward one. And what we're going to do is we're going to say, and this is going to be just straight up, how many millimeters will we have if we measure a length of 8 meters? Okay. Oh, what did I do? That happens all the time. So essentially, we need to know a little bit of background about the meter. Okay. It turns out that the prefix milli always means 1/1000th of something. All right. So if I have a milligram, it's 1/1000th of a gram. If I have a millimeter, it's 1/1000th of a meter. If I have a millivolt, it's 1/1000 of a volt, and so on. If I have a milliamp, it's 1/1000 of an amp. Okay. Wherever I put milli in front of some, measurement unit, it means 1/1000th of that unit. Okay. So if I'm talking about the meter and I say millimeter, what I mean is 1/1000th of this meter. Okay. So we divide it into tens. Each of those tens into 10, and each of those tens into tenths, and then we get millimeters. And if you look at a ruler, you'll see the smallest divisions tend to always be the millimeter division, okay? So then what I can say to myself is, well, in 1 meter, I'm always going to have 1,000 millimeters, all right? And what I'm going to do with this is I'm going to create what's called a conversion factor. Conversion factor. And all a conversion factor does is it takes that, okay, and it writes it in slightly different language. So it will say there are 1 meters, or sorry, write this the other way. There's 1,000 millimeters for every 1 meter or per meter, okay? So that's the conversion factor that's going to tell us how many millimeters there are in every meter. Now what we're going to do is we're going to start with our 8 meters. And I think you probably already tell it's going to be 8,000 millimeters. It's not that hard to figure out here, but what we're doing is we're building a method where we can do it with much more difficult situations. Okay, so we have 8 meters, and in this converting system that we're building, we're always going to use multiplication. Okay, and what we're going to do is we're going to look and see here. Okay, this is the unit that I want to get to. This is the unit that I have. All right, and you'll see here we're going to actually do math with our units. And what we want to have happen is we want to have meters essentially cancel out. So let's look and see if that's going to happen here. And I'll let you know that it will. So we take our conversion factor and we multiply it in. What we get is this. We get 8 times 1,000, 8,000. And then we get all these units, they come along too. So we're actually going to do math with the units. Okay? So we're going to bring the units right through with us. So the units are going to look like this. Meters, millimeters, meters, -1. Okay? If I have meters times meters to the power of -1, what essentially that is the same as saying is, and I'll give you a quick, easy example of this. In math, we would say, okay, we've got 10 times 10 to the -1, which is the same as saying 10 times 1 over 10. 10 times 1 over 10 is just 1, okay? And anything multiplied by 1 is itself, so we don't need to show that. So in other words, if we have a to the meters and we have to the -1 meters, those will cancel off, and the unit that's left behind when we're done is the unit we were looking for all along, okay? So if when we do this system, the unit we were looking for all along is what is remaining, that's a pretty good indicator that we've correctly done the problem, okay? So we're doing math not only with just the numbers or the magnitudes, we're also following math rules on the symbols that we have for measurement. Okay, I'm going to speed up a little bit here, but what if you have 1 kilosecond? So this is the next example. You have 1 kilosecond. How many nanoseconds is this? So you might have to go to a reference sheet if you don't know, but we'll just throw this over here on the side. Okay. Power of 1, we've got deca, right? Power of 2, we've got hecto. Power of 3, we've got our kilo. Power of 6, we've got our mega. Power of 9, we've got our giga. Okay, and if we want to go down the scale, deci, hundredths, centi, thousandths, milli, micro for millionths, and nano for billionths, right? So deci, centi, milli, micro, so that mu symbol, and nano. Okay? So what I'm saying is, how many, if I'm at the -9, okay, how many nanoseconds would there be in a kilosecond? All right? So we're going to use 2 of these conversion factors now. We're going to use this like kind of list like this to figure out what we're doing. Now the short answer is there's a trillion of them. Okay, and I can know that by looking at this. But we're going to use this method. Okay, it's a foolproof way of sorting this out. So what I want to do is I want to go from kiloseconds, and I have 1 kilosecond. Okay, and the first thing I want to do is I want to get it to seconds. Okay, so we want to go from kilo to second. So for every 1 kilosecond, that's the equivalent of saying 1,000 seconds. Okay, so our conversion factor that we're going to write out for this then is there are 1,000 seconds per kilosecond. Does that make sense? Just to save a little space, how about 1 times 10 to the 3 seconds per every kilosecond? 1 times 10 to the 3 seconds for every kilosecond. Okay, so why don't we start with that? Well, I know if I have 1 kilosecond, I'm going to multiply it by this conversion factor that I've just created here. Remember, we're always multiplying while we're doing these conversions, these dimensional analyses. And we're going to do first the math with the numbers. So 1 times 1 times 10 to the 3 is just 1 times 10 to the 3. Kiloseconds to the -1 is going to cross off. And we're going to be left in terms of seconds. Well, that was easy, right? I had 1 kilosecond, so that means I have 1,000 seconds. Just do that right from here. 1,000, right? Now, the second part sometimes throws people for a loop because they see a -9 here, and they're like, well, a nano is always to the -9. But remember, what that's saying is, if I have a meter, I'm dividing that meter up into 1 billion little parts. 1 billion little parts. There's 1 billion of them in every meter. Okay? So what we could say then is there is 1 billion, 1 times 10 to the 9 nanometers existing inside of, oops, why am I saying meters? I should be saying seconds. How do I erase here? Sorry, slipped into the wrong units. There's 1 times 10 to the 9, but there is 1 times 10 to the 9 nanometers, but we should be talking in seconds. So if I'm talking about a length of time, there's 1 times 10 to the 9 seconds, or sorry, nanoseconds in a second. Okay, so 1 times 10 to the 9 nanoseconds exist for every second. So here's our correct conversion factor in terms of nano. So we're going to take where we ended off before, which was here. So my 1 kilosecond is the same as saying 1 times 10 to the 3 seconds, 1 times 10 to the 3 seconds, times 1 times 10 to the 9 nanoseconds in every individual second. And seconds cross off. Oh, and I should keep my per kilosecond on here. My bad. That's 1 times 10 to the 3 seconds per kilosecond. That's still on there. Okay. And then once that crosses off, what I end up with is, well, 1 times 10 to the 3 times 1 times 10 to the 9 is 1 times 10 to the 12. 1 times 10 to the 12 nanoseconds per kilosecond. And the good thing about writing it this way is that this is an equivalent way of writing it. Doesn't matter which one comes first or after because you're multiplying. So here's the answer. For a kilosecond, you have 1 trillion nanoseconds. All right? This will become clearer as we practice with it. But a little side note, if you're just doing direct conversions like that on the metric system, you can actually just go right up the scale. So I'm going from -9 up to 3 in terms of orders of magnitude. So I got to go up 12. So that's where our 12 comes from, and that's how I got it right off the bat. You don't need to worry about that. This step-by-step way is the way that I would start off always doing this. Okay? Let's try one more. Let's try one more thing here. Let's see if we can convert between 2 different units of measurement. All right? Let's say that I am 6 feet and 4 inches tall. I want to know what that is in terms of centimeters. Okay? Now here's some stuff that I know. I know that 1 foot is the same thing as 12 inches. So I'm going to make a conversion factor out of that. I'm going to say there's 12 inches per foot. Okay. And up here, before, we learned that there was, I think, 3.28 feet in every meter. Okay. So, like that. And the other thing I think we'll need to know is the centimeters to meters part. Okay. Okay. So there's a few ways we can go about doing this. I think the way I'll do it is I'll convert 6 feet and 4 inches. Since we're dealing in kind of 2 separate units describing the same thing, we all have to get that compressed into just one type of unit. So we can put that all the way over into feet. So what I need to know is how many, in terms of feet, what fraction of a foot 4 inches would be. Okay, does that make sense? So that's how we're going to start this out. We're going to convert this all into feet. Then we're going to go from feet to meters, then from meters to centimeters. That's going to be my approach to this. Okay, so let's do that first. Let's get 6 foot 4 inches just into feet. So if I have 4 inches, okay, I'm going to multiply by the conversion factor that takes inches to feet. Okay, but I look at it and it's written in this way. It's written as 12 inches per foot, and I want to go from inches to feet, and I want to make inches cancel off. But the way I've got this written, that's not going to work, is it? Because inches are positive, they're not to the -1, and inches are positive, they're not to the -1, and it's foot that's to the -1. So I'm not going to get an answer in terms of feet. I'm going to get an answer in terms of squared inches per foot, which is not what I want. So what I have to do is I have to modify the way I have written this. And the way to do that is I'm going to need to invert it. Okay, so I'm going to write a little note. If necessary, invert. So mathematically invert your conversion factor. So what do I mean by that? Well, I'm going to take this, I'm going to write it on here. I'm going to say 12 inches per feet, but I'm just going to leave that off for a second. I'll show you why. So what I'm going to do is I'm going to invert this. To invert it, I do that, right? That's not a mathematical inversion. But when I invert the actual value in here, what I'm also doing is I'm inverting the signs on my units. So my signs now become inverted themselves. So I get per inch foot. Or in other words, 1/12 of a foot is an inch. This is what I'm writing, right? There's 1/12 of a foot in every inch. Does that make sense? Yeah. This is the same as saying that there is 1/12 of a foot per inch, right? Because if I have 12 inches, I have 1 foot. So every individual inch is 1/12 of a foot. Does that make sense? So that's what we're doing here. Okay, that's what we're saying in words, but mathematics-wise, what we got to do is we say, okay, so I've got 4/12, right? 4 times 1/12 is 4/12. Inches cancel off. I have 4/12 of a foot. Okay? And if I want to reduce this, that equals 1/3. Which is the same as saying in a decimal 0.3 repeating. Okay? So 6 foot 4 inches is like saying 6 1/3 feet. So now we've got rid of inches and we're just speaking in the language of feet. Does that make sense, what we did there? And just for ease, and I know like math teachers are not happy with writing it this way, but we'll round it off and we'll say we're 6.333. Essentially it's repeating, but we'll just round it there. Feet tall. Okay, perfect. Got rid of inches. We're dealing in 1 unit, just like we want. Now what we want to do is we want to go from feet into a unit we're looking for, which is the metric system. So we want to go to meters. So we're going to go, okay, we're starting at 6.333 feet. And we're going to multiply it by our conversion factor, 3.28 feet per meter. Uh-oh, we're going to run into that same problem. Our units are not correct, so we have to do the old inversion, right? The reason being is because if I'm in meters, I'm going to have more feet than that, right? I'm going to have more feet than that. So if I have 1 meter, I have 3 feet. If I have 2 meters, I have 6 feet and change. If I have 3 meters, I have, what is it? Just lost my mind. Oh, 9. Sorry, it's 9. There we go. Okay. So what we're going to say is we have 3.28 of a meter for every foot. So every foot is 3.28 of a meter. Okay. So I'm going to do this. I'm going to convert 6 foot 4 inches into meters. So essentially what you're doing here, okay, is you're multiplying by 1 over 3.28. Multiplying by an inverted value is the same as just dividing by that. So on your calculator, you type in 6.333 times 1 divided by 3.28. Well, the times 1 part is just like saying 6.333, and then you're dividing by 3.28. And if you do that, you get about 1.93. 1.93 meters. Okay, we're almost done. The last thing to do is to take those meters and change them over to centimeters. So 1.93 meters times the conversion factor that we had before, 100 centimeters for every meter. Okay. Now notice feet canceled off over here, right? So they're out of the picture. Now we're just in terms of meters. Now we got to cancel off meters, so we look to make sure. Okay, good. And we should end up in centimeters, which is just 193 centimeters. Okay, we're going to wrap that here. Okay. Next time we're going to look at, well, what happens if I have 2 units going on at one time? Like, for instance, I'm talking about rates. So 100 kilometers per hour to, meters per second. Okay. How do we go about dealing with that? But that's for next time.